Hey there, and welcome back. Today we are looking at 39 and 40. So they are kind of sibling problems. Almost their solution to it is almost the same. So let's see the problem here, combination sum. So it's an array kind of problem, and so he wants us to get a combination to sum up equal to the target. We have an example here. We have an array of elements which is 10, 1, 2, 7, 6, 1, 5. So we need the one of the combination. So for 39, we can use each element infinite times. For example, if we have a target like 12, we can use 1 for 12 times. That's no problem. But in problem 40, we can't use the same element again. We can use this element in different positions, but we cannot use the same element again. And so we're gonna use approaching of one of the recursion. Someone call it backtracking. Many people call it desperate search. Whatever it's called, that doesn't matter. It's a recursion concept to it. So we're gonna write a help function trying to discuss in either position we're gonna use it or not. So in this case, the time complexity is going to be 2 power of n, and we need to sort the array first before we starting to recursive working on it, because if we are not sorted, we might miss some combination right there. And yeah, because the recursion we're gonna follow the order of the string, we might missing like separate parts. Okay. So here's the combination sum one. We first sort the array, then we can initialize the results and new an array list of integer list. And here comes the help function, the recursion function or backtracking function, finally return result, of course, then the help function itself. So there are two conditions we can end jump out of the loop. One is the target is smaller than 0 or target equal than 0. Equal than 0, we just put the result into the result array. If the target is smaller than 0, that means the combination doesn't exist, so we're gonna just return. Otherwise, it's going to be the target still there. We still need more element to add up to it. So we're gonna loop through the rest of the array and add the candidate into the current template array list, and recursively go to the next target. And since here that we can use the element another time, so we don't increment I until the I is not working. We gonna increment 10. So every time the combination did the combination, gonna start doing the combination from the scratch. So we're gonna use the array list to remove all the element in the array list and do it again. Else, if target is equal to 0, then we get the answer, add to the result. So let's see if this can pass. Yeah, it passed. It's not very fast. It's fine. Then let's look at the combinations of 2. So this time we can only use one element only once. So basically, the most of the part of the code is about the same. We have to sort first, and we're gonna use the recurring function to recursively check the target is equal to 0, then add to it and return. If it's small, then it works. It's not. It's illegal, then return as well. And here is the difference. If we encounter the candidate is equal to candidate, we equal the candidate before, which means we use the second times. That's not allowed. Then we have to continue to work on the next I and pass add as candidate number add and reset the pass. Submission. Okay, we gotta use the submission 2 years ago. Yeah, I did this problem once. It was 2 years ago. Actually, 2 years ago, I'm not even clear about the recursion concept. Now I'm getting good to it, better. So yeah, it passed. Those kind of problems, it has been very popular in interview questions, and I think I've been asked once in one of the interviews. Yeah, see you in next video.